All right, so section 3.3, Foundations of Math 30. It's entitled Intersection and Union of Two Sets. Now, in the other lessons, in 3.2 especially, I talked about, I mentioned this word intersection, okay? And the intersection, if you think about an intersection, right, it's where two streets meet, right? The intersection out here, right, Albert and 23rd, that's an intersection of the two streets where they overlap, right? So you could be standing right in the middle of that intersection, and you would be on both streets, technically, right? Got it? So that's, when you think about intersection, you think about a Venn diagram, and like I say, if we go back to our notes here from the other day, okay, so this part right here, that would make sense that if you're in here, you're in both subsets, right? Just like in a street, if you're standing right in the middle of the intersection, right here, that's where you are. You're in the intersection. You're in both streets. So this is the intersection when we talk about intersection. And it's only this part. This is the difference between intersection and what we're going to talk about as well. Union. This is the intersection, just where both intersect. Okay, let's go back to the text. And I'm not sure how many of you think this little creature is cute or not. Is that a raccoon? I mean, a baby raccoon. Anyone look at that and smile and tilt your head a little bit and think this is the cutest thing ever? Some of the girls. Okay, all right, good. Okay, that's good. My daughter would really think this is cute. This would totally distract her. I don't know. I grew up on the farm, and these guys just always got into our garbage and stuff, so it's not cute to me. But anyways, okay. So Jackie's a zookeeper, though, and she's responsible for feeding any baby animal that can't be fed by its mother. So she needs to feed this baby raccoon every 2 hours and the baby lemur every 3 hours. She uses a 24-hour clock to plan their feeding time. She starts to feed the raccoon at 2 and the lemur at 3. All right. So you can see what's happening every 2 hours for one, every 3 hours for another. There's maybe going to be a time where they both have to be fed at the same time, right? And so I won't go through the whole example here, but let's take a little clip of the definition here of the intersection. Just talk about that for a minute. So the intersection here, as we've already mentioned, is basically the overlap of two or more sets. So let's read it. It says, the set of elements that are common to two or more sets. That's what the intersection is. So the elements that are common to two or more sets. Now in this section, we're just talking about two sets. We're going to just keep it simple for now. But you can have 4 or 5 different circles or different subsets that overlap. And wherever the region is that's common to all of them would be the intersection to all of those sets. There could be a part that's just common to 2 sets, and that would be the intersection of the 2 sets. So this is important. In set notation, this is the notation denoting the intersection of A and B. So let's talk about this for a second here. It's not an, this is an A, okay, set A, and this is the intersection symbol, okay, just like that. When I think of intersection, I think of and. So this is sort of like an A. It's not an A, right? But it sort of is like an A. If you just did this, it would look like a big A, a big rounded A. But I read this. This may help you to remember because there's intersection and union, okay? And it's helpful to think about the wording of this to help you distinguish the two. So this is A and B, okay? That's the intersection. So it's just the overlapping part. All right? So let's take a look at this example here from the definition here. So for example, if subset A is the numbers 1, 2, and 3, and subset B is the numbers 3, 4, and 5, then A intersection B, okay, I think of it A and B, you actually read it A intersection with B, is the one number 3 there. See how it's in both sets? So just a review from yesterday, let's do that. We know there's going to be an intersection, so let's have subset A and subset B. And A has 1 and 2 and 3. Now where should I put 3? Right here or somewhere else? Should I put it right here? Yes, no? I'm seeing some apprehensive head shaking. Okay, well, let's take a look at B. So B is 3, 4, 5. Does something sort of look wrong here from what you know from 3, 1 and 3, 2? What should I change? Put 3 in the middle. Thank you. Does everyone see that? Yeah, okay. 3 should go in the middle. All right, yes, I know that was a terribly easy question. I think you guys were psyched out. It's like, I think that's really easy, but he's not framing that question like it's an easy one. Okay, so yeah, 3 would go right in the middle there. All right, because it's common to both. And again, the intersection would be this part right here. All right? Any questions? All right, so let's go back to the textbook here now. And if we take a look at, okay, this graph is really helpful. But we're going to take, so we took a look at the intersection part here. What we're going to do is we're going to take a look at the union part, okay? So union, let's just clip that definition here. Union. Let's put it over here. So if we take a look at this definition, union, it's the set of all elements in 2 or more sets. Okay, so not the ones that are just common, but all of the elements in 2 or more sets. All right, so union. When I think of union, obviously this notation is really easy to remember because this is like a big U in the middle, right? So that's going to be pretty easy, right? A union B. Okay, so that is union. So intersection is just where it overlaps, but union, you think about the entire package. When I think about union, I think about holy matrimony. I think about marriage. The two have become one, okay? And so you have 2 separate sets, but they are now become one. And so you consider everything in either of those sets to be part of that union, okay? So there's another way of looking at it here. We can draw the same, let's do the same example. 1, 2, 3, 4, and 5. Okay? Now we know the intersection is this part in the middle right here, but the union would be everything in either set. So the way I like to think about it, see how the and up here for intersection, and only where it overlaps? Union, I like to think of or. Okay, so it's A or B. All of them. That's union. Okay, the 2 shall become 1. Now we've got one big set here. So in our example, they use the same example here. A is 1, 2, 3. B is 3, 4, 5. So A union B would be all of the numbers. 1, 2, 3, 4, and 5. Okay? Intersection, only the ones that are in common to both. And union, everything that's in either one, either or. Okay, any questions about intersection and union here so far? Yes, no? We're good? Okay, so on page 166 we have a Venn diagram here. The universal set, okay, would be, and it looks like these are all of the sports or the activities that a large high school offers, okay? That's what the question says. So the universal set is everything, okay? Got that? Okay, that's pretty straightforward, right? Universal set. Now, what B is and what I is, we could probably figure that out without looking at your textbook. Don't look at your textbook. Without looking at your textbook. Anybody have any ideas what the subset of B would be versus the subset of I? And if you have already looked and know the answer, just give a few seconds for those that haven't yet. How would they have separated B with I? Now there's some overlap, but if you look at that, what does it seem? Maybe the B might even give it away. Anybody? The sports that are in B, what do they all have in common? Ball. Yes. The sports in B all use a ball in the playing of that sport, right? Tennis, lacrosse, golf, basketball, rugby, all use a ball. The ones that aren't in there, hockey, okay, use a puck, curling, a big rock, badminton, a birdie, right? Or a shuttle. So this is balls, this is, now, but what about these? Because tennis is also in I, and lacrosse is also in I, and softball is also in I. So what do we need to add to make sense of this diagram? Why would these be in here if these don't use a ball, but these are also in I? Yes, exactly. The sports in I use some sort of stick or some sort of weapon, right? That's what we call them. I mean, in hockey. But anyway, it's a big piece of lumber. But yeah, okay. So you think about it, tennis uses a ball and it uses a racket. Okay. What about badminton? How come badminton's not in there? Why is badminton not in with these ones? Ah, because it uses a racket, but not a ball. Everyone seeing that? That's why badminton is not in here with tennis, lacrosse, softball, and golf. Okay, so golf club, ball, softball, bat, ball, lacrosse, ball, and actually, what do you call that? The net thing. Thank you. Yeah, that's what I was going to say. I was hoping someone had a better. Oh, that's sad. Actually, I don't know that, but was it like a wicket or something? I don't know. Sorry. Tennis. Okay, racket and ball. All right. So what about ultimate? I'm assuming this is what? Ultimate what? Is it ultimate frisbee? Okay. So why wouldn't ultimate frisbee be in here then? Doesn't use a stick. And why would ultimate frisbee not be in here? Because it doesn't use a ball. Okay. So we have a frisbee, but that's not what these subsets are all about. Okay. Good. And wrestling. Okay. Cross country running. Cross country skiing. Does everyone see why these high school sports are kind of separated the way they are right now? Does that make sense to you? Okay. Yeah. Would cross-country skiing be in the red circle? Okay. Why do you think it could be in the red circle? Because it has two sticks. Okay. That's a good point. Maybe it should be an I. Okay. If you were making the Venn diagram, then you might put that in I, and I think that would be logical. I would be fine with that. Okay. Now, what about if I did this, B, and then this symbol, and I, okay? What am I putting in this set? Anyone? Tennis, lacrosse, softball, and golf. Awesome. We're putting these ones in. Because this is the intersection, right? Where B intersects I. And you would list tennis, lacrosse, softball, golf. Put the braces in there. Okay? Not teamus, that's tennis. Okay. Alright, so that's good. What about if I change this here, eventually, to this symbol? What would I be putting in this set? B union I. What was that? Everything in both circles, yes. Rugby, soccer, volleyball, basketball, football, tennis, everything here. Not the ones that are outside, but the ones that would be in B or I. Okay? All of this inside here. Does everyone see that? Any questions or any clarification that you'd like there? All right. Okay, I think you guys are well on the way. Now, we did talk about, in the last lesson, we talked about, and I'll leave this diagram up here. Okay? I talked about this. The number, remember this little n? This refers to the number of elements in B. And so that means we count up all of the things in B and we put that number down. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So the number of elements in B is 9. The number of elements in I is 1, 2, 3, 4, 5, 6, 7. Okay? What do I mean when I write this? What does this mean? That means what? What does it mean in words? The what? The number. Okay, union. What? The number of elements in the union of A and B. So that means the number of sports that are in either circle, right, that are in both combined, okay? So how many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12? Okay, did I get that right? 12? Now, why is this down here, the number of elements in A union B, why is it not 9 plus 7? Because 12 is not 9 plus 7. Okay, because we have some sports that we have double counted. So obviously tennis, lacrosse, softball, and golf are in both. So I've counted them here, and I've counted them here, right? So this comes up with a principle, and we'll write this down instead of cut and pasting. I want you to write this down. The principle of inclusion and exclusion. And basically what this says, and you don't have to copy all this down that I'm going to show you here, but it's on this page right here, and we'll just kind of summarize this. But this is what it says. It says the principle of inclusion and exclusion is the number of elements in the union of two sets is equal to the sum of the number of elements in each set with this important part right here, less or subtracted the number of elements that are in both. And so if we write that down in set notation, it's going to look like this. Okay, I'll spare you the words because they're in the textbook, but this is what it looks like. Okay, so the number of A union B elements is equal to, and you guys have already figured this out already, but it looks like this. The number of elements in A plus the number of elements in B minus, and we subtracted the ones that we said we double counted. And so how can we write that in set notation? How can we write these ones, or this number right here in set notation? That would be the number of A what? What do I put here? A intersection B, right? A and B. Okay? So we just take, because we've counted that number twice, so if I take one of them away, it's like I'm eliminating the double counting part. Okay? Make sense? All right? Okay. So I'm hoping you understand this. This should be fairly straightforward for you. Again, if you have to take another look at it, you can certainly go ahead and do that. I will just kind of direct you to the summary in your textbook, which is really good. So let's just zip down there. All right, and let's just go over this real quick here, okay? Yeah, there we go. Okay, so key ideas. The union of two or more sets is A union B. Consists of all the elements that are in at least one of the sets. It's another way of putting it, right? Everything that's in these ones here. It's represented by the entire region of the sets on a Venn diagram. It's indicated by the word or, so we use that word or. Now notice that if the two sets are disjoint sets, A union B would simply be the number of elements in A plus the number of elements in B. Now if we subtracted the number of elements that were in A and B, what would we be subtracting in this case right here? So I'll say that one more time. That principle that we just took a look at, right, which is not showing up here. Sorry, I have to kind of reset it. There we go. So this principle right here, you see this? The number of A in union with B would be the number of A plus the number of B minus the number of A and B. So back to the textbooks here. How many elements would be in A and B at the same time in this one? So how many elements would be A and B for this one right here? Well, since there is no intersection, there's none, right? So you would be like subtracting 0. So we haven't double counted any. That's why we're subtracting 0. So that principle still works even if the sets are disjoint. All right? That'll make sense later, if it doesn't make sense now. Okay, the intersection. So the intersection of two or more sets is symbolized by this right here, A and B. So we see and it's simply the region where they overlap. Okay, and over here, A and B is an empty set. That's what I was trying to get at up here. A and B is an empty set. There is no overlap. Okay. little more explanation of the principle of inclusion or exclusion. Don't think we need to go over that right now. Okay, this part here we haven't gone over yet, and I think I'll probably just take a quick second to just talk to you about this right here. Okay, elements that are in set A but not in set B are expressed as A, and then this is sort of a backslash B. So let's just write this symbol down here so that you can get that. And I think that we'll maybe not do this one right now. Okay, we'll not go over this right now in detail, but let's just add that final thing to our notes. So A, and then this symbol there, kind of a little stroke, a backslash there, means the elements in set A, so you read A first, and then but not in set B. That's what that means. So the elements in set A but not set B. That's what that symbol means. Okay, so that concludes lesson 3.3. I'll give you your assignments here coming up, and if you have any questions at all, you can let me know, and I can go over whatever it is you need to go over again.